It was 1936, the Great Depression was 7 years old. Incumbent U.S. President Franklin Delano Roosevelt was up for re-election and faced Republican Alf Landon. The Literary Digest, an influential weekly magazine of the time, had begun a political survey. The magazine had polled a sample of people based upon telephone and car registrations. The results that they obtained predicted Landon would win in a landslide with over 57% of the popular vote. The actual results gave a very different picture. Roosevelt won by one of the largest landslides in presidential election history. The survey polled over 2 million people, yet it missed as badly as possible. What happened? The process of drawing conclusions about a population that is based on a sample is called statistical inference. Samples have variations because it takes only a subset of a population. The sample will only approximate the population because of natural and explainable variations, and because the sample is not a complete picture of the population. Sampling errors will exist. A sampling error is any difference between sample value and the population value that arises because the sample size is limited. It refers to the deviation of the sample results. A sample is not a perfect representation of the population. A sampling error is not an error. It doesn't occur by mistake. It is not caused by bad procedures. Sampling error exists because you are just taking a sample and not surveying the whole population. There is nothing practical you can do when sampling to avoid sampling error. The only way to avoid a sampling error is to test the entire population, which is almost impractical. Doing it in that case isn't a sample, but a census. A non-sampling error is a statistical term that refers to an error that results while collecting data. Because of these mistakes, the data will differ from the true values. Examples of non-sampling errors are sample bias, voluntary bias, undercoverage, non-response, convenience sampling, and population specification. Sample biases are common non-sampling errors. A sample bias is a systematic over or under representation of a population. Some respondents are given a better chance of being selected for the study. Some have less chance or no chance of being selected. For example, a survey of high school students to measure the use of the online library service will be a biased sample because it does not include homeschooled students or those on a leave of absence. To illustrate, it is when only a portion of a population is given a chance to be part of a sample, and the rest of the population were not given a chance to be randomly selected. Voluntary response bias is when respondents are all volunteers of the study. This bias occurs when sample members are self-selected volunteers. An example would be a radio show that conducts a survey by soliciting calls from its audience. The resulting sample will tend to overrepresent individuals who are avid listeners of the radio station. Undercoverage is a form of sample bias. Undercoverage occurs when some members of the population are inadequately represented in the sample. Some respondents are not given a chance to participate in the study. A classic example of undercoverage is the Literary Digest voter survey, which predicted that Alfred Landon would beat Franklin Delano Roosevelt in the 1936 presidential election. The survey sample suffered from undercoverage of low-income voters. The survey relied on people who own cars and telephones. During the Great Depression, not everyone could afford a car or a telephone. These people tended to be more affluent. Low-income earners were left out of the survey. In non-response, many respondents do not give the response to the survey. In other words, survey forms or questions are left blank. Sometimes, respondents are unwilling or unable to participate in the survey. In convenient sampling, respondents are chosen because they are easily accessible to the researcher. The sample are easily reached because they are in close proximity to the researcher. This neglects potential participants that cannot be reached easily. This bias also causes undercoverage. Population specification error is an error that occurs when the researcher does not understand who they should survey. For example, imagine a survey about breakfast cereal consumption in families. Who should be surveyed? The entire family, the person who most often does the grocery shopping, or the children. The researcher may choose the person doing the shopping because the shopper might make the purchase decision, but it is actually the children that influence the cereal choice. This kind of non-sampling error can be avoided by planning the research questions. The sample size represented by the N statistics is important. In general, the minimum sample size is 100. A good maximum sample size is 10%, but it should not exceed 1,000. Take note that this is recommended for basic surveys such as feedback forms, needs assessments, opinion surveys, and surveys that use random sampling. Also note that sampling error increases with large populations, so the right sample size is important. To reduce non-sampling errors, the researcher must, number 1, choose the appropriate sample size. The right sample size is important. Researchers must be careful because sampling errors increases with large populations. Once you reach a certain number of respondents, typically around 500, additional responses tend to deliver diminishing returns. Number 2, having strong sample design, which means avoiding all the non-sampling errors discussed earlier. Generally, the larger the sample size, the more accurate the research. However, if there is bias in how participants are selected, sample size doesn't matter. Just like in the Literary Digest Presidential Survey, wherein they had 2 million participants, but these participants were chosen from one strata of the society. And number 3, reduce bias influencing who respond, who do not respond, or make sure everyone participates in the study.